Alright guys, so we're finally working with quadratic equations. In this video, we'll be pretty much graphing quadratic equations and covering what is called the vertex form of a quadratic equation. So the simplest thing we can do, pretty much the simplest version of a quadratic equation, as we can see in here, it's y equals x squared. This is the simplest form of a quadratic equation. Pretty much the greatest exponent is 2. That's what will make a quadratic equation. So let's try to graph this. Any function can be graphed by making a t-chart. So here's my t-chart. Let's fill in some values for this t-chart and then plot my points. So on my paper here, I have my t-chart already done. So let's start putting some values to find my points. So I like to usually choose -2, -1, 0, 1, 2. These are just random values, but I usually like to choose like the negatives and then 0 in the middle and then 1, 2. Alright, so x is -2, -1, 0, 1, and 2. So let's see y equals, let's say if x is -2, I'll get -2 squared. I just replace the -2 into the x, so I get -2 squared, and -2 squared, that's -2 times -2, this becomes 4. Alright, so first value at -2, I get y to be 4. What if x is -1? If x is -1, I would get y equals -1 squared. And -1 times -1 is +1. So at -1 I get +1. Let's see, at 0 I get y equals 0 squared. 0 times 0, that's 0. So at 0 I get 0. And see, at +1, so y equals +1 squared. This is 1 times 1, 1. Get 1 again. And finally, if x is +2 squared, 2 times 2, that is 4. So at 2 I get 4. Alright, so now let's plot these points. So the first one I get -2, 4. So at 1, 2, at -2, my graph goes up 4. 1, 2, 3, up 4. So at 2, I get 4, somewhere there. That's my first point. My second point, it's -1, 1. So at -1, I go up 1. At 0, I get 0, so that's the origin, 0, 0. Then I get that at 1, I get 1, so 1, 1. And then at 2, I get 4. There. Now, if I wanted to, I could go further. Let's add another point. Let's say that y equals 3. So if y equals 3, I get y equals 3 squared. And 3 squared is 9. So at +3, pretty much my graph is going to go all the way up to 9. And guess what? If it was -3, my graph will go all the way up also to -9. The graph will look something like this. It's going to be increasing like this and keeps going up. Same on the other side. It keeps going up. Looks like a U. Pretty much. So here I graphed it in the Desmos site. The graph of y equals x squared, and there's the graph, precisely how we got it on the paper. We see that at +1, the graph it's up 1. At 2, well, the graph should be at 4. Let's see if it's actually at 4. So here's 4, that was 1, 2. So we got this. This is how the graph is supposed to look, and that's one way to graph it. Alright. Now, you have these words So all quadratic functions make a U-shaped graph called a parabola. However, adding to, subtracting from, and multiplying the function by certain numbers can change the graph by shifting it, reflecting it, or changing its width. So transformations like shifting up, shifting down, shifting left, right, what we've seen already. The vertex form of a quadratic function is, let me write the vertex form. The vertex form, so let's write it over here. Vertex form is y equals a times x minus h raised to the second power plus k. We'll go over each of these terms during class. I'll cover some of this in this video, but it's pretty much the vertex form. You really want to know this form. We'll be using it a lot. All right. Let's go back to the sheet. So the vertex form, you got it where the vertex is at. So there's a specific point. Using, let's say you can find the vertex form of a quadratic equation. There's something called a vertex point. This vertex point, it's located at h, comma, k. All right. Notice that in my equation, in this equation, h is negative. Here is positive. Pretty much whatever h is gonna be the opposite. So let's say that it was -2. My vertex point will be +2, and my k, it'll be the same value. Okay, the h is the only value that will pretty much change signs. That's my vertex point, and that'll be what we want to have in here, h comma k. All right, always make the vertex the origin of your table, then choose values on the right and left of it to create the u. All right, so choose values to the left and to the right. Now, what is the vertex point? Let's go back to our graph. In my graph, my vertex point was this point here. This is my vertex point. It's pretty much either the lowest part of the graph or the highest part of the graph. This will be the lowest because it's a upside up graph. If I had an upside down graph, this would be my vertex point. All right. So vertex point. And when graphing, let's say that you have to look for values to the left and to the right of this point. Okay, and you should get a U-shaped parabola. Okay, let's go back to our sheet. We have an example here of a quadratic equation in vertex form. Notice that I have my values here, there, my negatives, and the squared. Okay, so this is a vertex function. So let's graph it. All right, so I haven't taken a look at this graph, how it looks, but just by looking at pretty much the numbers, I can say that this is going to be an upside down graph. Okay, it's going to be shifting up 5 units, and it's going to be shifting to the right 2 units. But the first thing we can do is finding the vertex point. Find the vertex point. Before graphing, let's find the vertex point. Again, I told you it's going to be our h and our k. This value here is our h, and this value here is our k. Alright, so again, I told you that it was going to be, first off, h is going to be the opposite. If I have a -2, my point is going to be the opposite of -2. It's going to be +2. And my key doesn't change. It'll be 5. 5. There you go. This is my vertex point. This will either be my lowest point on the graph or my highest point of the graph. Okay? Again, this is your H and this is your K. So let's graph this point. It's 1 to the right, and then 1, 2, 3, 4, 5 units up. So 5 up, and to the right, my point is going to be here. This is my vertex at 2, 5. There's my vertex point. Alright. Now, let's start graphing. Again, I told you to choose numbers to the left and to the right of my vertex point. So the number in the center should be 2, because that's pretty much where the graph is. We need to choose points to the left of 2 and to the right of 2. So I know my 2 is going to be in the middle. Now to the left of 2, that will be like 1 and 0. 1 and 0. And to the right of 2, that means like 3 and 4. 3 and 4. Alright, so now we have some values. We can start making our graph. Alright, so let's start from the top. From the top, we get x equals 0. So I'm taking my graph, y equals, I have the negative, parentheses. I like to make another parenthesis for the x, then minus 2, that squared, plus 5. And we said that our first x value is going to be 0, so let me put a 0 where x is supposed to be. Alright, let's simplify this. We get negative, and here we get 0 minus 2, let's choose minus 2, squared, plus 5. Simplify the thing inside. I get negative 2 squared. Negative 2 squared, that is negative 2 times negative 2. That will be positive 4. But then there's a negative outside. So this will be a negative 4. Remember, so negative 2 times negative 2 is positive 2. Times the negative. Oh, negative 2 times negative 2, positive 4. Times the negative, negative 4. Don't forget the plus 5. Negative 4 plus 5. This is equal to positive 1. So at x equals 0, my y value is 1. At x equals 0, my y value is 1. There's my point. My first point. 1. Let's see the second one. At x equals 1. So again, I'm making my graph. Y equals, there's my negative, parentheses. Let's put a parenthesis where I'm going to put my x value, minus the 2 squared plus 5. Okay, this gives me, I said x was going to be 1 in this case. So I get equal to negative, and then in the inside first, I get positive 1 and negative 2. That gives me negative 1 squared plus 5. So negative 1 times negative 1 is positive 1. And the negative makes it negative 1. Plus, let's not forget our 5. And negative 1 plus 5, that's positive 4. So at 1, I get positive 4. Again, at 1, I'm going to go for up. There. Nice. Let's throw a point in the middle. X is going to be 2 in this case. So again, let's repeat the process. Y equals the negative, the positive 2, the negative 2, squared plus 5. Alright, so I replace my x value by positive 2. Let's see what we get. We get the negative. Now here, positive 2 and negative 2, this becomes 0 squared plus 5. Okay, let's simplify this. 0 times 0, it's 0, and the negative, it's still 0. So here we get 0 plus 5. And 0 plus 5, that's just equal to 5. So at 2, my y value is 5. It's going to be 5. So at 2, I go 5 up. And there I am. I'm good. Okay. Let's try now at x equals 3. At x equals 3, let me go down here. Y equals, let's not forget our negative, parentheses. The parentheses, where I'm going to put my x value, minus the 2, and then that squared plus 5. We said x was 3. There's my 3. So let's see what we get. Equals negative. Alright, continuing, we get negative 3 minus 2 gives me positive 1 squared, and then the plus 5. So negative positive 1 squared, that's just 1, and the negative outside makes it negative 1 plus the 5. This gives me negative 1 plus 5. It's going to be positive 4. So at 3, I get positive 4. Alright, last one. It seems like a lot, but it's just a repeated process. Last one, we get y equals my negative, parentheses where I'm going to put my x value, and then minus 2. And that's squared plus 5. So now my x value is going to be 4. So I'm going to put my 4 in here. So let's simplify this. My negative outside, I get 4 minus 2, that's positive 2. Squared plus 5. Now 2 squared, that's 4. The negative is outside, so I get negative 4 plus 5. Negative 4 plus 5, that's positive 1. So at 4, my value is positive 1. 1. Alright, now we can start plotting our points. Well, I plotted 3 of them already. Oh my goodness, a mosquito! No! Okay, it went away. Alright, the number at x equals 3. Let's see, at x equals 3, what do we get? Almost caught the mosquito. Oh, didn't catch it. Okay, at x equals 3, I get that my y value, it's going to be 4. So I'm going to go 4 units up at x equals 3. And that's somewhere there. And then finally, at x equals 4, I go up 1 unit. There you go. So my graph should look something like this. Going down. Sorry for my horrible graph. Something like that. Going down. Should be an upside down U. So this is my graphing. This is all of my work. A lot. The good thing is that we have shortcuts. We'll go over the shortcuts later on. Before that, we have to kind of find out how to graph functions using other methods. But let's say that I wanted to graph this another one real fast. Let's say number 3. I'm going to graph it as fast as I can with as minimal work as possible. All right. So let's try to do this. We have y equals, and well, there's my function. So let's do this as fast as we can. All right. So let's from the beginning. I have y equals 2 times x plus 1 raised to the second power. Alright, that's what we have. I'm not even gonna make a t-chart. Here's the place where I'm gonna graph it. First off, my vertex point. My vertex point. Notice that I have no number here. I usually have like a +5, which in my other problem I had a +5. That was my k. Here we have no number. Well, that no number can be expressed as a +0. So there's my k. It's +0. Pretty much, if there's no number, there's pretty much a +0. That means my vertex is gonna be, remember, the opposite of +1. It'll be -1, comma, and then my k is 0. So my vertex point, it's pretty much at -1, comma, 0. There is my vertex point. Alright, this is going to be an upside up graph. I have a few other things to do. It's going to be an upside up. I know my graph is going to be something like this and then going up. Another important thing to find, it's either X intercepts and Y intercepts. This one, the graph is going to go below the X axis. It's a positive, so it's going to be an upside up U. That's one thing. Also, it'll only have one Y intercept. Let's find that intercept. Okay, to find the Y value, pretty much my Y intercept, it's located somewhere where X equals 0. So if I can let my Y value, my X value to be 0, pretty much that'll give me my Y intercept. Again, so let's do this. Let's let my X value to be 0. X became 0 plus 1 squared. X became 0. This will give me the Y intercept. Okay, where X equals 0. There's the 0. Okay, the Y intercept. That's how we find the Y intercept. So this gives me 2 times, well, 0 plus 1, that's just 1 squared. And then I get 1 squared, that is just 1 times 2, 2. So when X is 0, my Y intercept is 2 units up. 1, 2. 2 units up. I have this point, my Y intercept. I know my graph is going to go through it like this, making a U shape. And it's also going to go this way. Notice that it's 1 unit to the right and then 2 units up. Well, the other point over here, it's going to be 1 unit opposite, so this to the right. It's going to be 1 unit to the left and 2 units up. It's supposed to be there. And from there, it's going to go up as well. One really nice thing about parabolas is that they are symmetrical. You can draw a line of symmetry through them, and they pretty much are a reflection of each other. Alright? So pretty much if you can find points on this side, make a line of symmetry and reflect your points. Okay? Just reflect your points. You won't even have to graph that to make a lot of equations. So this is the graph for number 3, pretty much. Now I'll let you try as many methods as you want to answer the rest of them. Well, the rest of them is just one more. It's a little bit different. Do whatever you can, do whatever you want to do to graph it, except using Desmos. Do not use Desmos to graph it, because on the test you won't be able to use Desmos. That's it, guys. See you in class tomorrow, and have a good day.